Hi guys, welcome to Elixir tutorial part 4. My name is Tensor from the Tensor Programming blog, and today we're going to take a look at GenStage. A short summary of what GenStage basically does is it allows us to handle a real-time stream of data in a distributed way. So we can assign multiple processes to basically pipe this data into our file or program or whatever we want to put the data into. So we'll go more into detail for this when we actually build our project here. So let's start building our project. We're going to use mix, and we're going to say new gen counter, and we're going to add an extra argument that we haven't added before, and this is --sup. And what this will do is it will generate a boilerplate supervisor file for us. Let's cd into that folder and then open the gen counter in our Sublime Text. So here's our gen counter program, and as you can see there is a folder in here called gen counter under lib with an application.ex, and in here is our supervisor boilerplate that was generated by mix. As you can see, this supervisor is basically complete except for the fact that it doesn't have any children, of course, because there are no children processes for it to watch. Also, if we look in our mix.exs file, you can see that it's set up the application to actually run with this mod and then the application name. Okay, so GenStage is not currently a core library in Elixir, so we are going to add it as a dependency. To do that, we're going to put it inside of this list down here. We're going to say with an atom GenStage, comma, and then the version number, so this will be inside of a tuple, and then we'll put a comma after it and save this. Then we can go back to our terminal and write mix do deps.get comma compile, and this will allow us to perform two operations. One of them will be getting the dependencies, and then the other one will be compiling those dependencies. It compiled our GenStage dependency, and then it compiled our gen counter application, even though there's nothing in it currently. So there are three different pieces to a GenStage project typically, and those pieces are called a producer consumer, and a consumer. So let's start with the producer first. So we're going to create a new file, and it's going to be appropriately named producer.ex. So we want to create a producer that emits a stream of numbers, because this is going to be a counter. It's just going to be simulating a stream of data. So for example, you could think of this, instead of numbers, you could think of this like if you were getting JSON from a HTTP source, or if you were reading a very large file. It would be very similar to what we're doing here. So let's, of course, define the module first, and this will be genCounter.Producer. We want to use GenStage. We want to make a startLink function. Inside of this function, we will put an init variable, and we can actually define what that init variable's value will be with two backslashes. So we're going to define it with 0. So we can call this function without actually declaring init, and if we don't declare init, then it will default to 0. And we will link this to GenStage.start link. Inside of it, it will be very similar to our gen server in that we will want our module atom. So the name of the module. So we're basically wrapping our module with this GenStage behavior. And then we want our init, sort of like our state in our gen server. And then we want the name. In this case, our name is just going to be the module name as well. Then, of course, we want our init callback, and this will have our counter in it. And we can make this a single line function, because all it's going to do is call back with producer and counter. So it's going to set the state inside of our GenStage, and it's going to call back and set up the process. We also want a function called handleDemand, and this function will take in demand and state, and we will say events equals enum.toList. And what this will do is it will allow us to create a range of numbers and then put it into a list in a lazy method. We're going to have a range from state to state plus demand minus 1. So this will allow us to create a very large amount of numbers, actually infinite numbers if we let the program run for as long as we want. And then we will return a tuple of no reply event and then state plus demand So the init function, of course, is setting the initial state, and this is very similar to our gen servers, but it's also labeling this particular module as a producer. The response of saying producer this atom is telling the process that it is a producer. Basically, this function is what GenStage is relying upon to decide what exactly this module is supposed to do. Then the handle demand function is where the majority of our producer is being implemented. So what we're doing is we're returning a set of numbers which we are demanding. We can choose how much we demand at a given time, and then we will get that set of amount of numbers. Of course, our consumer part will actually make that demand. So the demand from our consumers, represented by the demand here, is an integer that is corresponding to the number of events that this producer can handle at one given time. This one in particular, this defaults to 1,000. So now let's make our producer consumer, and this will be producer underscore consumer.ex. And of course, this module will declare it as genCounter.producer consumer. This is kind of the middleware in our GenStage. So we're also going to use the GenStage module inside of this module. And we also want to require the integer module. And this will allow us to do a few things that are sort of like type checking, and I'll show you what I mean. In this module, we also want a startLink function. This function will take no arguments, and it will call GenStage.startLink. We'll pass in the module atom, then we'll pass in an atom called state, and we'll pass in the name, call it module again. So this atom called state is just a filler. It doesn't really matter in this case because state doesn't matter inside of our producer consumer. Our startLink is going to have an init function. This will take in a state variable, and it will return a tuple of producer consumer state, and then we want to fill in this field of subscribe to with the producer that we want this to subscribe to. In this case, it's our genCounter.producer. This will go inside of a list. Next, we need a function to handle the events. So def handle events. We'll pass in the events from, and we'll also put an underscore next to from because we're not going to explicitly use it in the function. And the state. We're going to define a variable called numbers and pattern match it with events piped into enum filter. So enum filter allows us to lazily apply a function to a list. In this case, we're going to use an and sign, and then we're going to call integer dot is even. And what this will do is it will let us basically call this isEven function on our list that we're piping through here. And we're going to just put in the RT of the function. This is kind of a Erlang thing. It's nothing you really need to worry about. We could write our own isEven function if we wanted to make this a little bit more clear instead of using this syntax. So then our tuple at the end will be no reply numbers, which is this here, and then the state. So basically what we're doing is we're going to be counting up infinitely with infinite numbers, and then we're only going to show the even numbers. So even though we're going to deal with all of the numbers, we only want to really send the even numbers to our consumer, so we're filtering out the numbers that we don't need. So again, our init function is like what we did in our producer. We are defining this process as a producer consumer, and then our subscribe to is telling this particular module that it needs to be in communication with this other module, with our producer module. Our handle events function is where all of the work is happening. So we receive our incoming events in this events variable, process them, and then return them as a transformed list. So as I said before, we will just be returning the even numbers in this from this particular function, and then pushing them through to our consumer file. So this is kind of similar to how our consumer will be defined, though there is one minor difference. When we label a process as a producer consumer, the second argument of our tuple, this number, is used to basically meet the demand of our consumers downstream. If we were dealing with the consumers, then this value itself gets discarded. So let's create the consumer and show you what I'm talking about. So our next file, of course, is appropriately named consumer.ex, and our module will be gencounter.consumer, and we're going to use GenStage. And again, we want a startLink function. This function again will take no arguments, and it will call the GenStage.startLink function. We'll put in our module name again, and then we'll just put in a atom that just says state, and we won't have a name for this consumer. So we also want an init function again, and remember these inits are callback functions. So these are functions that are deployed by the process itself as a response to the startLink function happening. In a way, GenStage is basically an abstraction above a gen server. It's just made specifically to deal with big pipes of data. So we want this init function to subscribe to our producer consumer instead of our producer. So we will put in here subscribe to genCounter.producerConsumer, and then we will have a handle events function like we had in our producer consumer. In here we will have a for loop. So Elixir has for loops. They are a little bit different than for loops in other languages. So as you'll see here, we will say event, and we will have a backwards arrow, and we will say events plural do. This is sort of like a for each loop in JavaScript, or like a for loop in Python, where you can say for I in, a list, for example. We're saying for a single event inside of our list of events, then do all of this stuff. And what we're going to do is we're just going to say IO inspect. So we're basically going to print to the screen, and we're going to say self, comma, event, comma, state. Finally, we're going to return a tuple of no reply, then a empty list, and then the state. So the reason why we're using this IO inspect is so that we can actually see all of the data coming through this consumer. So our producer is going to produce an endless stream of numbers. These numbers are going to go into the producer consumer, and then they're going to be filtered out into even numbers, and then our consumer is going to print them all to the screen. So now let's actually wire our application up with our supervisor. We will have to define our worker for each of our processes. We have 3. So we have our producer consumer, and our consumer process. And we can, of course, define more if we wanted to, and multiple different processes. So for our first one, we want to say genCounterProducer, and then we want a list with 0 inside of it. That's because we want this to start at 0, so the initial value will be 0. Next one will be the producer consumer, which doesn't have any state, so we just pass an empty list to it. And finally our consumer, which again will be passed an empty list. And we want to keep everything else the same for what we had before. So we're keeping this as 1-to-1, and we're just going to use this supervisor here. We can jump into our terminal, and we can actually run this and take a look at what's happening. We're going to say mix run, no halt, and go. Alright, so here we are. As you can see, it's counting up. There's one process, and I just kind of paused it by doing that. And it keeps going, and it's going pretty quickly. So this is a very simple GenStage example. Now we can do some pretty cool things with this, so let's stop this for now. Let's jump back into our application. And the main use of GenStage is to actually use multiple processes to handle the data at the end. So we want multiple consumers. So we will define a second consumer in here. And of course we need to differentiate these two, so we're going to put in an ID here. So for our first one, we'll just call it ID of A. And then for our second one, we'll call it ID of B. Now if we run this, let me pause it. As you can see, the data is being processed by 2 different processes. And as you can see, the numbers are actually being processed in a weird order. So if you remember in our producer, I mentioned that our demand defaults to 1,000. So each of the processes took a demand of 1,000. So this process here, the PID of 154, took 0 all the way up to 999 as its demand. If you think of that as a set of data, then that's the set of data that it decided that it was going to go through. Our other PID, 155, took the demand of 1000 up to 900 or 1999. So if we continue to let this run and let it go past 1000 up to 2000, as you can see, it reassigns how it distributes the data. We got up to 196, 198, process 155 immediately started at 2500 and process 154 started at 2000. So it looks like the demand changed. So in this case, this one's only taking 500 demand, and I'm not sure what this is taking until it finishes. And this is probably because the CPU couldn't allocate more to these processes. Let's now assign 3 processes. So if we create another consumer process, then we're going to call this one C, and then we rerun our program. PID 1 is taking from 1000 all the way up. PID 2 is taking 0 to 1000. PID 3 is taking 1500 all the way up to, I am assuming, 2000. And because these processes are very lightweight, the more that we actually add, the faster this will actually go. So the thing to really keep in mind when dealing with streams of data like this is, first of all, when you want to use a distributed way of dealing with data, you have to remember that the data will not necessarily come out in any particular order. The other thing to keep in mind is that GenStage uses a lazy method of evaluation. So there are 2 main methods of evaluation for data. One of them is called eager and the other one is called lazy. Eager means that you evaluate all the data all at once, and this can obviously cause problems when you're dealing with really large amounts of data, because you're basically saying, okay, just take all the data and do it at once. So for example, the way I like to think of this is like if you're playing a video file on your computer. A video file doesn't need to buffer, it doesn't stream anything, it's just reading the file that's on your computer. But if you're streaming something, you're going to have a little bit of latency because you're streaming bits of data onto your computer. And that's a lazy method of evaluation. So you're basically saying, okay, we're going to read the entire movie, but you don't necessarily have to have the entire movie saved on your computer to view it, so you can choose which piece of data you get to see at what given time. And that's basically what GenStage is doing. We're defining how much data we want to see through our demand, and then we're allocating that to our processes. Alright guys, well I hope you enjoyed this quick tutorial on GenStage. In the next tutorial I will be trying to look at the register, as well as some of the other cool features in Elixir that we haven't gone over yet, and then we will be transitioning into Phoenix Framework. If you enjoyed this video, feel free to like and subscribe this video. If you have any questions or comments, feel free to comment, and if you disliked it, then of course, by all means, go ahead and downvote us as much as you'd like. Alright guys, well I hope you have a good night.